Hey, what is up, guys? It's the AI Wizard Show Part 2, and I have Stig Bosmans here with me, and we are
Hello.
ready to we're ready to chat about all sorts of interesting topics, AI related or not. We'll see. We'll see. It usually like goes like to all sorts of places. So
Yeah,
okay,
yeah.
start like tell a little bit about yourself, like some backstory.
Okay. So I studied applied engineering a couple of years ago, and after that I started working in two companies. First, healthcare company Johnson and Johnson, as
Mhm.
an IT analyst, but it was not technical, and I really didn't like it because of that. So I switched jobs after that to a more development role. It was front end development, and actually it was there that I started working with AI. But I
Mhm.
also did some work in Johnson and Johnson in healthcare with AI. But mostly my first hands-on experience with AI was in my front end job, which I really liked, and starting there I got interested in AI
Mhm.
uh, and decided to
And
pursue a
and and
PhD.
and how long ago was that?
Well, I gotta think. It's about 3 years ago, I think.
Okay.
Yeah,
Okay,
three
so
years.
you've studied for applied engineering, right?
Yeah,
Yeah.
correct.
So you get a job in healthcare, but it's not too practical, and you want to like get your hands dirty and build stuff. Yeah. So you
Exactly.
switch it
Yeah.
to to where again?
Yeah, it was like a small
Uh-huh.
startup company. It was mainly focused on yeah, business process engineering and so on. And I was a front end developer, so way more technical stuff. But we were doing some research projects.
Mhm.
And I was mainly working on these research projects, and one part of it was like some security platform where we did like audio, yeah, like voice recognition,
Mhm.
things like face recognition,
Mhm.
fingerprint recognition, all these things, and we just used public APIs for that. But then we wanted to do something extra and combine all these different
Mhm.
security measures and try to predict unusual behavior to see if we need to have extra security measures before someone can log in or something. And that's when I started looking at neural networks and saw
Uh-huh.
some unsupervised learning techniques.
So it's kind of like when banks or e-commerce platforms they use kind of similar algorithms to detect fraud and that sort of thing. So you've started to look for ways to make those security systems more robust, right?
Yeah, correct. Yeah, so it was a
Mm-hmm.
partnership with Vasco. It's a very big security company.
Mm-hmm.
They had an office here in Belgium. I'm not sure if it's a Belgian company or not, but they do a lot of
Mm-hmm.
security works for security projects for banks and so on.
Okay.
So maybe you remember these like little devices. I think I have one here,
Yeah.
like
Cool.
this, like these things. Do you
Mm-hmm.
know them in Russia?
It looks like a calculator to me.
Yeah, yeah. Well, you need to put your credit card in it, and then
Okay.
it generates a code,
Mm-hmm.
and you use it to authenticate on your home banking or something. So that's what we use here in
It's
Belgium anyway.
is it like the thing that you pay with in a supermarket or in a store or in a shop, or
No,
is
no,
it like
it's really for home banking only. You use it here at
oh
home, and it's
okay
like some kind of two-factor authentication, I guess. And all the banks here in Belgium
uh-huh
they use these devices and they're provided by Vasco. But this is like
mhm.
really ancient technology. It's already 5 years old, and they wanted to replace it by things like face recognition and so on.
so, so like let me just know if I'm getting the purpose of it correctly. So it's kind of a another level of security. If you want to pay for something from like your home, you can plug your card in, enter the password, and it'll kind of confirm the transaction. Is that kind of the way it
Yeah,
works?
yeah,
Okay.
yeah, exactly.
Uh-huh.
Yeah.
Okay. I don't know. like the reason why I kind of started to talk about like supermarkets and all that, I see a lot of those in supermarkets. So when it's kind of not a big one, when it's like a big one, you can just just kind of put your card there. You don't even have to enter much if you're buying products for less than about $20 in
Yeah,
rubles
exactly. Yeah. It's similar, but these we only use for
at
the
home.
home banking. Yeah, but
That's actually pretty cool.
yeah,
I've never seen those in
yeah.
around
I'm
here.
surprised. I thought everyone was using them or had been using them in the past. But
Well, but I mean like I mean all the times that I've paid for something on the internet, it's basically asking me to like enter my credit card information and then the I don't know what that little code that's called security code,
the
another
CVC code. Yeah,
yeah on the back of the card. And it's basically all it took for me to pay. And then if it was Amazon, it like send me a message on my phone to like confirm stuff. So yeah.
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 But this is for the debit cards. So you always need
Oh.
to have enter your code before you can authorize a transaction, and that's why you need something to enter your code, and
Hmm.
then you can use it. So with credit cards, you don't always need to use your PIN code. So I
Mhm.
guess maybe that's a difference.
Yeah. So like if you're buying something on the internet, that's what you gotta have like by your side in your pocket maybe to
Yeah,
like pay.
yeah.
Yeah. Okay.
Otherwise you can't buy anything. At least it used to be like that.
Okay. And have you like while working there looked at maybe some studies? I don't know that like countries or places that use these devices for another layer of authentication. Like, are there less fraud and is it like safer? I mean, I guess it is, but like, have you seen the numbers or something like
No,
that?
well, actually, I'm not sure. I'm really not. I don't know a lot about security, so
Okay.
I
Well,
really.
I guess it's safer because like uh, in my case, I guess if I like fall asleep and some burglar or like whatever, someone breaks into the house and like takes my credit card, buys something, then I like wake up and all my money's gone. Yeah, I mean that's actually a lot
Yeah,
safer.
exactly. Because it like it generates a token after.
Hmm.
But first you need to authenticate with your PIN code, and then it generates a token, and this token you can use. So there's really also it's not connected to the internet, the
Hmm.
device,
Oh.
so they can't get your information directly. You really need to have this device
Hmm.
in order to steal credit card information or something. So
Yeah. And you enter your PIN code like that, like every single time you buy something online. So
yeah,
that's all it works.
it's
Okay.
a hassle. Yeah,
But I mean that's secure. I guess like I would rather spend extra 5 seconds doing that than lose
yeah, true
money.
story. Yeah, exactly. We're getting too lazy
Yes.
sometimes,
Uh-huh.
and then you forget about security and privacy. But it's important.
Of course. Yeah. So you work in that startup that gets partnered with that big security company.
Yeah, correct.
What are you working on there? So I mean, just keep telling the story.
Yeah. So maybe what I was working on was, as I said, I was mainly doing this front end development. Then we tried to build a POC to do authentication, like face authentication,
Mhm.
fingerprint authentication, things like that. And one of the things that we also looked at was, okay, how can we try to predict if some authentication action is trustworthy or not. So,
Mhm.
for example, what we try to do, and that was an algorithm that we looked at, is okay, what is happening when someone logs in at a very unusual time in a very unusual place, and
Mhm.
maybe we need to take this into account when trying to authorize someone to use a service or something.
And when that happens, that's kind of the info get passed on to a person who then reviews it and then kind of tries to decide how
Yeah,
safe was
well,
that.
it was just a POC, so the we were just developing the technology and
Hmm.
how it would be used. That's something else, of course. So we were really looking at the technology and seeing what is possible and we didn't move to like production type systems. So of course, yeah. I think that's the most interesting part, because you don't need to worry about moving your product to production. You can just explore different technologies, experiment with them, really learn about it, make some conclusions, make some recommendations, and then
And I
move
guess like
forward to something else. And that's the research mindset. Yeah, go
and
ahead.
I guess like that's where kind of the partnership part came into place. So you were kind of trying to come up with ideas and better ways to that, and that big company would have then take your ideas and kind of put them into production on a
Yeah,
bigger scale.
exactly. Yeah, that's
Yeah.
the idea. Yeah.
So what happens then?
Um, yeah, so what happens then? It's a POC. I'm not sure what happened with it ultimately, because I left the company a couple months later. I only worked there for like a year or something, because
And now
that
and that was like 2 years ago, or like year and a half,
yeah,
or
2.5, I think.
okay, 2.5. Okay,
Yeah,
I
two and a
see.
half, 3 years, something like that. Because then I was really enthusiastic about doing AI and experimenting with AI, and then I started with Andrew Ng's, or Andrew I think, I don't know how to pronounce it.
I don't I do not know that too. I mean, I'm just kind of coming up with like a weird pronunciation in my head and then hope that I will never have to speak that out loud. So kind of that's
Yeah,
how I'm rolling.
exactly.
But he's a cool
I
guy.
think actually it's Andrew or something.
Yeah, it's
But
something of like Chinese origin, I guess.
yeah,
Yeah.
yeah. NG is easier to pronounce for me.
Yeah.
So I started with his machine learning course on Coursera. Um, you probably know that one. It's like one of the most famous courses.
Yeah, yeah, yeah.
Yeah.
I checked
So
that one.
yeah, it was really great. I started with that one, and then yeah, I was really into that. I really liked it a lot, and I decided to do research again. And I come.
And like how kind of hard was that with like your base, and like you mentioned that you were studying the engineering, so I mean what amount of effort did it take to kind of make the transition to like doing AI and learning it?
Well, I I already I knew somewhat about AI, not very
Hmm.
much, but I use it in my master thesis. I used neural networks
Hmm.
to do some predictions, but I didn't know what was running behind the covers. Let's say I didn't know
Hmm.
how exactly it was working, but I knew about AI, so I worked with it, and then Andrew Ng's course really motivated me to start. Looking under the covers of AI, let's say,
Hmm. Hmm. Yeah.
and by then I already had some experience with MATLAB. We used
Hmm.
it also during my masters, so that was quite easy for me. And then I think Andrew just does such a good job in explaining it, making it very very intuitive. So it felt kind of natural, and I just started
Hmm.
doing the exercises, and yeah, I think the pace was just great. And after a month or two, I really felt that I had learned a lot of things,
Hmm.
and was able to start applying them.
So
So
and
that
what
was
and what kind of like little projects for learning were you like making along the way in those like 2 months like?
yeah. Well, I'm not sure what I did back then. What kind of projects? I think I did some like I tried some face recognition projects for my home security, things
Mhm.
like that. Always some
Mhm.
hobby projects. But the thing is, I always get bored at the end. I start something,
Hmm.
I read about it, I learn about it, and that when I understand what it's doing and I can
Mhm.
implement something very basic, I
Yeah,
kind of
you
get
kind of
bored
move
and
on.
move to the next.
Yeah, 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 yeah. I get that too sometimes. I guess it's quite
Yeah,
natural.
yeah.
So, okay. And so the pace was pretty quick. And when you and like, what do you decide to do next with that?
Um, I think so. So what I did next was I contacted my master thesis promoter
Hmm.
because he already asked me to do a PhD prior. So that's like when I left university. So I contacted him again and said, okay, I'm really interested in doing things with AI. Is there a possibility to start working on a PhD? And then a couple of months later, there was a position I could
Hmm.
start. It was related to mainly related to AIs, but mostly related to Internet of Things,
Hmm.
partly to AI. And now I'm 2 years later, I think, and still learning a lot, still
So,
trying to.
and how long was that when you started to do your PhD?
That's like October 2 years ago.
Okay, so you've been in the game for a while.
Yeah, now
Yeah.
it's yeah. I still have like 1 year and a half to finish my PhD.
Okay, so you're like 60% through, or
Something
about,
like that. Yeah.
yeah, something like that. Okay, so I'm actually a responsible host, so I went and checked your papers, and there was like a lot of interesting stuff on Internet of Things,
Yeah, yeah.
and could you kind of start begin the conversation about it by telling what excites you about the Internet of Things and maybe how you think about it of its like definition?
Yeah, okay. That's I'm gonna try to do it as good as possible, but
Sure.
there's a lot of things that excite me about IoT, so I'm gonna try
Okay.
to articulate it correctly.
Okay.
So mainly what I think is very cool is, hey, with Internet of Things you have all these devices connected to the internet, and that's the main idea, of course. They're all generating data, and if you look at how IoT is being used these days, it's mainly in a very reactive way.
Mm-hmm.
You mainly, it's like you use a sensor for checking the temperature or something, and then it triggers something else. Um, or for example, how I use it here is like when it's let's say 6 o'clock or something, I automatically trigger my radiator to start my heating
Mm-hmm.
system. Things like that. So it's all very reactive. But I think there's a lot of potential given the fact that there are so many devices. I think it's about 20 billion, going
Mm-hmm.
towards 50 billion devices connected to the internet.
Yeah, I've heard
And
the
I,
50 billion number.
yeah,
Uh,
so and they're all generating this data, and I think there's a lot we can do with it, and really beyond just using it for reactive applications that trigger when a certain threshold has surpassed. So what I'm really looking at is how will an IoT, a large scale IoT system, look in 10 years or something, and how can we really add intelligence to these IoT systems, and that.
there was really a lot of emphasis on decentralization of those techniques in your papers, or at least like that's what I've picked up.
Um,
Yeah, was
yeah,
it?
exactly.
Uh-huh.
Yeah, so
Yeah, yeah.
that's the architecture part. So if you look at how these things work nowadays,
Mhm.
you often have a centralized server that is processing data
Mhm.
and aggregating data from various sensors.
Mhm.
But if we want to move towards very large scale systems that run on city or country scale, we will need more decentralized approaches. And um, and that also brings me to how I really look at Internet of Things devices. I don't see them as a single device, but really as an agent that has the possibility to interact with other agents, with other IoT devices,
Mhm.
and with the environment directly. And if we take this decentralized approach, maybe it's possible to let them learn to interact with each other and
Mhm.
learn to work together, collaborate with other sensors, and try to optimize global behavior. If, for example, if you want to
Mhm.
optimize traffic flow, maybe we can have traffic lights that are connected to each other, can talk to each other, can share information with each other. and try to optimize their traffic light schedule to optimize throughput, and do that all dynamically, automatically, and I think there's a lot of potential there, but we're not there yet. It's a very difficult case, and what I'm really looking at is how can we simulate these systems, because I think the first approach is to go to a proper simulation of these large-scale environments, and try to develop algorithms to test and calibrate the behavior. So that's really a first step I believe that we need to take in order to get towards a fully automated, adaptive, multi-agent Internet of Things environment.
And what are the areas like I don't know, like what are the areas where you kind of can see that the Internet of Things is like more developed than in the other areas, like where the meat is like now?
So you mean like with areas? Well, what exactly do you mean? Like
I mean areas like I don't know, e-commerce, healthcare.
Okay, yeah, okay, something like this. Yeah. Well, more we're doing a lot with smart cities here in Antwerp. We have this smart city zone where we're trying to connect all these different things with each other. We look at communication technology. We look at making this communication technology like use very low power, and we have this what we call smart zone where for example traffic lights are connected. I think trash cans, like the public trash cans, are connected. If they are too stuffed, automatically someone from the city will be notified and can come and clean it up. So things like that is I think there's a lot of potential there.
So have you gotten a chance to like put your hand on on the improvement in Antwerp, on like that smart city concept and project?
We did a POC which was mainly related to how do I say, it's a smart part sensing system where we use citizens to collect data. And it's not fully IoT, because with IoT you're mainly thinking about sensors and devices. But we had a system where we asked citizens to collect data related to their environment. Like, for example, do you feel safe in this neighborhood? How clean is the street? And that's a thing that we did specifically in the smart zone. So we built a system to collect this data and try to really get a good overview of what's going on in the city. Try to get, for example, a good idea of where the safe neighborhoods are, where the neighborhoods are a bit more dangerous, for example, or less clean, or things like that. Just by collecting data from citizens who are participating. That's a POC that we did.
And like, how were you like asking those questions?
Yeah, so we worked with it. Of course, again, it's a POC, so we didn't add a fully operational, not yet. Actually, we don't have a fully operational system yet. But we tried some questions, and it depends on the stakeholder. In our case, we thought, for example, that the city itself could be the stakeholder, and they could formulate the questions. And it depends, of course, on what they're interested in, what they're trying to solve. So really, we just created this platform, and it depends on the stakeholders what they want to do with it. Just it's an opportunity to collect data efficiently, qualitative data, not just quantitative data, because with IoT you're gathering quantitative data, of course.
And when like a lot of people are asked the questions, who like goes through them and kind of forms the basic picture? Like, are there some, algorithms or something that extracts the meaning from potentially like thousands of of answers from the citizens.
So you mean really the data processing when you gather all these different answers? How do you process them and how do you?
Yeah, exactly. Yeah.
Well, again, there we were really focused on building the algorithms to collect the data as efficiently as
Okay.
possible, not the part behind it. But what we looked at was how can we make sure that citizens aren't bothered too much, and if someone already answered a couple of questions this week, maybe we should look for someone else and we try to balance. It's of course a trade-off because you're trying to maximize the amount of responses you get, but on the other hand, you don't want to bother participants too much because maybe they stop using your service.
Yeah, I mean,
So
yeah. Uh-huh.
yeah,
It makes a ton of sense. Like if you know somebody with like an you kind of try to ask them a question and they like think, oh, like it's those guys that asked me 79 questions yesterday. Like get away from me. I'm gonna
yeah,
go and live.
exactly.
I'm gonna go and live in the mountains. There are no smart cities there. I can just sleep under the trees and drink the rainwater.
Yeah,
Yeah.
maybe it triggers a response like that. And that's what we're trying to prevent.
Yes,
It should
yes, and
help people, not bother them.
yes, and it's the right thing to do that.
Yeah.
Okay, okay. It actually reminded me of how I don't know where it's used, but I've definitely read about how police uses some data science to kind of predict the areas in cities where the crimes are most likely to occur, and then they like send more police basically there to kind of patrol around and prevent them.
For example, yeah, that's a
Yeah,
use case. Yeah, of course.
yeah. And what can be like some other use cases here?
Yeah, so what we also thought about, I think another one was for example, the safety of let's say, how do you say it in English, like bikers. We have a lot of bikes here in Antwerp. We're close to the Netherlands, so a lot of people are cycling, and maybe we can also gather information about the road quality and how they feel cycling on the road. Maybe there are some dangerous spots somewhere in the city, and if we want to prevent accidents, we can try to collect this data, and based on this data, we can share it with the authorities, and they can look at solving the issue, for example. So that's another use case. But of course, there are plenty of use cases. It's all about how can we gather this qualitative data gathered by the people. It's like crowdsourcing, and how can we make the most value out of it.
Yeah, and I guess for now you're asking them questions, but in the future that would be like the bike with like smart tires that would kind of feel when it bumps through something, or like maybe some
Yeah,
little
yeah, of
cameras that would
course, yeah,
detect them, and it would automatically send those signals
yeah.
to.
Because we, we,
I,
we even have we even have like another use case. It was a different project, but also about my co-developed with my university and my research institute. And what they did, they built this device connected to the bike, um, where where people can say that they're happy or they're not happy about the road quality or something while they're cycling. So that's really it really allowed us to collect a lot of data, and try to identify spots that are safe or unsafe and so on.
so, so like, did you actually get a chance to kind of see like the way I kind of see it now is that, for instance, there is like some spot in the city where a lot of cyclists said that there is something bad with the
Yeah,
quality of the
yeah,
road, and you would
exactly.
like go and check what was happening there.
Yeah, so you can maybe ask the participants directly why was it bad or something.
Yeah,
I
sure.
think this use case was mainly related again to road quality and potholes and so on. But yeah, you could the city authority again could use it to to fix the road and come and have a look and see, is there really an issue? Is there really a dangerous situation or something? And then look to solve it. But it's all POCs. I
Yeah.
don't think they're using it yet in practice.
Yeah, but I mean, like, it's definitely the kind of thing that you can imagine, like, a lot of devices in a lot of the cities of, of basically future, but it's not like the far away future, but like the 10-year away or something. Yeah,
Yeah, exactly. I mean, it's all something we can do now. We have the technology available at the moment, and
Yeah. I don't know if you kind of heard about it, but if we like had those little buttons in Russia, like there would be a lot of red places here where the roads aren't that great. It's
I can
like,
imagine.
I mean, the climate is tough, so sometimes, yeah, like there's quite there's quite a potholes
Yeah.
here. Yeah.
So, how's the weather now where you live?
Now I could actually show you. I
Wow.
live a bit outside the city, but I studied in the city, and that's kind of how it's outside my window now. I'll tell you I'll tell you like the weather. The weather is minus 16 Celsius right now.
Minus 16. Wow, that's crazy.
It's Siberia, man. That's how we roll here. You put up a bunch of warm clothes and hope that you won't freeze to death on your way home.
How do you do that? And what city is it actually where you live?
I mean, you mean like with all the like temperature stuff?
No,
You
I mean,
mean
what's the name of the city?
Novosibirsk? It's like the capital of Siberia, basically.
Okay.
So it's
Cool,
like
cool.
in the heart of it. But like there are a
In the
lot
heart of Siberia.
Yeah. I mean, not really though. Like there are a lot colder places in north where it's like minus 45 Celsius in the winter times, and that's like a normal weather. Here it's like minus 15, minus 25, and when it's like minus 30 Celsius, it's like cold, and when it's minus 35, you may not go to school, or
Yeah.
something like that.
It's crazy. I think now
And
it's like 5 degrees here, and already for me, it's like I want to stay inside, and it's way too cold.
oh, so it's 5 negative or the 5 like just 5 positive, or
5 positive, 5 positive.
Yeah, it's warmer, but the summer's pretty good here. It's like 20 to 35 degrees, so it's nice here in summer times.
That's great.
And you can like explore a lot of wildlife, I would say, with like skiing, and so like there's a lot of fun stuff that you can do here in winter time. So
That's awesome. I should come one day.
yeah, I mean, I could like give you a couch if if you come. I mean, like I can let you into my Siberian how do you say that, like in my little house in my little cabin in the forest that's
Yeah.
that you just like stops with like wood and to warm up. we can sit there, talk about AI and the Internet of Things, watch how the bears walk by and the wolves. Like,
That
what a
sounds
romantic picture of the future.
Well, actually, I think it's Bill Gates. He has like every year he goes to a cabin in the woods for a single week or 2 weeks or something, and he focuses just on studying each year. He's fully isolated from everything, and that makes him like hyper productive, and he can learn new things. He can read a lot of books and things like that. So maybe
Walk several hours into the woods, there are really not many people that will disturb you. I wouldn't be so sure about the wildlife, but like I mean, although the bears are asleep, right? They sleep in the winter, so it must be fine. Yeah, but I also heard about like people kind of isolating themselves to learn. I think Sarash Ravel mentioned something in his Twitter that he like once a week disconnect from the internet. I mean, it's not like he goes to a cabin, but like just disconnects and kind of helps
Yeah.
him to be more creative.
Yeah, I
So,
guess so. I think definitely. I mean, it. I think we're spoiled with the internet. Always too many ways to get distracted.
yeah, instant gratification with it. We've talked a lot about it with Carlo in like on the first episode.
Yeah, but it's difficult because how do you try to be focused in such an environment where you always directly have access to something, like just
Yeah.
browsing your Twitter feed or browsing your Facebook and
Like, what do you think could be like the ways to do that better in the future? Because it's not really the like it's not really the healthiest way for like the human mind to, have all those distractions with like social media and like other things. Like, maybe you kind of ways that could be done better in the future.
yeah, I think of course you have them, and I'm definitely not against them because it makes it's very easy. For example, you meet interesting people,
Yeah,
like you, for example, and on
yeah.
Twitter, I
Thanks,
guess.
man.
I
It's
met
it's
Carlos on Twitter.
it's totally mutual here.
Yeah, so that is of
I'm
course
glad we're
great,
talking.
but I think really need to be aware of when you use it and when you shouldn't be using it, and that's something that I really try to do. I try to have set hours apart in the day where I can just focus on studying and focus on not being distracted and really say, okay, from now on to the next hour, I will fully focus on this, and I think that that's something that helps you really to be aware of it and try to work on being focused. And that
And
works for me actually pretty well.
for how long were you doing that? And do you see like the progress? Is it like sit down and I mean it's probably still takes willpower. Like of course it does,
Yeah.
but like do you see progress with it? And how you've been
Yeah, I
training it,
think
right?
the long in the beginning, I think I started doing it since the beginning of this year. I read this book from Carl Newman. I don't know if you know him. He's a
Cal Newport, the Deep Work.
Newman, I think. Newman. It's a yeah. He has a
Called
book called Deep Work.
Deep Work. It's called Newport, I think. I've
Is
read
it?
his book.
Okay, yeah, yeah.
I've read his book So Good They Can Ignore You. You know that
Yeah,
one? It's
exactly.
also
Yeah, that's the other one.
yeah. I really enjoyed that.
Yeah,
Okay,
yeah, it's really good.
I haven't read Deep Work, but I've watched his like interviews, his talks on that. So okay, uh, keep going.
Yeah,
What you learn
yeah.
from
So
there?
it's a really interesting book. I liked it a lot, and since then I've trying to put it into practice. And what in the beginning it was difficult, and I really had to force myself to not using my browser. For
Hmm.
example, there were some add-ons which really blocked you from using your mail, for example,
Hmm.
that I use. But over time it gets easier and easier, and you get used to it. If you really just have the willpower to do it, it gets better. And of course it's different for everyone. But what I try to do since a couple of months is when I get up, the first thing I do is start studying on a certain topic for a single hour. So before I go to work, I just study for an entire hour, and
Hmm.
that really helps a lot. And it because you're still very much focused when you get up. You don't
Hmm.
have the distraction, and you can just start working on something without being distracted about your email or about what was going on Twitter or Facebook. So for me, it works because you do it every day, and so in a week it's like 7 hours of being fully focused. Well, you progress a lot if you do it like that.
Hmm. Yeah,
I used to struggle
becomes
with
a
it
habit.
in the past. Sorry?
Yeah, it becomes a habit, right?
Yeah, yeah, it becomes a habit. My the habit I had before was when I get up, I just kept lying in bed for like 30
Hmm.
minutes scrolling on my phone, and I would say just get up
I've been
and
there.
get started. And,
Yeah,
it's so
yeah.
much better now.
Uh-huh. Yeah, what helped me is like I've got that alarm, and in order to kind of turn it off, you gotta take a picture of, and in my case it's a painting, and the painting is downstairs, so it's kind of like I have to get up from my bed, pick up my phone, walk downstairs, and get a shot of the painting, or otherwise it will not stop.
Yeah.
It's called alarming, and it really doesn't stop. I mean, sometimes I forget to turn it off, or sometimes it's like weekend I have to like completely turn off my phone if I just can't get up in any other ways. But usually I do.
Yeah. Of course, you can
Sometimes
still turn off your phone. Yeah.
if the music's nice though, I kind of listen to it a couple of times, and then like in 5 minutes I get bored, and I'm like, okay, now I really better like, now it's like kind of less boring to like go and wake up.
Yeah. Yeah, it's
Yeah.
difficult. I now have this app, and it monitors my sleep, and it tries to wake me when I'm I'm not in a deep sleep. So when it tries to predict when I will be in, like, how do you say, like REM sleep. So it's easier to wake up then, I think, and it really helps. So I just say I want to wake up between 6:45 and 7:30 or something maximum, and then it waits until it's the appropriate time to wake me up. That helps a lot. It's better than just fixed timestamp.
Yeah. I've read about it. Yeah, about the like REM sleep, and like when it's better to wake up in the sleep cycles.
Yeah.
Yeah, it's actually related to the Internet of Things in some ways, right? Like the smart beds would wake you. I mean, how does that how does that app work? Is it like is it like on your phone, or is it like
Yeah,
a
it's just
clock?
on my phone. It's an application, and I think it monitors my sleep quality using audio. It's a microphone or something, and apparently it's good enough to get an accurate view of my what sleep stage I'm in.
And like how does it work? Is it like listening to your kind of I don't know how to say it in English, but like
Yeah,
doing
yeah,
this in
exactly.
your
Like,
bed?
yeah, exactly. I think it's like that. So when you move, it will hear it, and it seems pretty accurate. I have it here. I can show you maybe.
Yeah.
It,
So.
I get an overview each day of how I'm doing. So sleep cycle. That's the name of the application I'm using. For example, it shows the
Okay.
waves like this, and at the bottom it's like deep sleep, and at the top it's like
hmm
almost awake.
hmm
So, yeah,
And it
it's
basically
really
tries
useful.
to wake you up in like those times. Yeah, when.
Yeah, when I'm almost asleep, then it tries to wake me up. When I'm in a deep sleep, it just probably will let me sleep for another 10 minutes or something.
And like how accurate do you feel there is? Like, does it work most of the times, or does it like
Yeah, well,
not? Uh-huh.
actually, it works very well. I'm surprised myself. For example, this morning I woke up. I thought I had a good night's sleep, but I felt like really tired, and I thought, wow, there's something wrong. So I looked at the app, and I saw I get a score. It's like you each day you get a score between 0 and 100. 100 is very good, 0 is very bad, and I had a score of about like 59% or something. So quite bad actually, and yeah, that's how I felt as well. So it's pretty accurate. Yeah.
hmm
59%. Yeah, yeah, I can really recommend it. It's quite good.
Yeah, I mean, is it on Android? That
Yeah,
that work
just
with?
on Android.
Ah.
I think also on yeah all the app stores. And what I also like is they have this feature that you just track. You say, for example, that I drank alcohol last night. You do it each time before you go to bed. You say you fill in your log. For example, I had alcohol, or I didn't eat very well, or I eat too much, or something like that, or I did sports, and then it's gonna try to predict based on what you
Mm.
did the day before how you're gonna sleep, and it's gonna really get the correlation between the quality of your sleep and what you did. For when I drink alcohol, my sleep is much worse. And when I do sports,
Mm-hmm.
it's better. The quality of my sleep is better. So it helps you to really see what works for you to sleep better. Pretty cool.
Okay. I mean, I'm actually gonna like write it down so I can.
Yeah.
It's not that I'm gonna like forget the name. It's that I can just not think about it and remember that after sleep cycle, right?
Yeah, sleep cycle.
Yeah, I think I could create like some weird combination with my with my like photo alarm. So it's like I don't know if I want to wake up at 8 a.m. I will like say, let's have that app try to wake me up at a good time, and if it's like and if I don't know if I refuse to wake up, then like there goes like the hard stuff and the photo alarm pops up and
Yeah, exactly.
wakes me
Yeah.
up either
You
way.
can combine the two.
Mhm. So are you doing some studies with other like elements of like smart home? Because that's it's pretty pretty hot, I guess, topic these days.
Smart home.
Yeah, like I don't know, some
Yeah,
smart.
well, I try to connect like my entire house with smart lighting,
Mm,
movement sensors, and things like that. Um, but there's, I put a lot of work in setting up such a system, but there's always a very major risk factor. And in
mhm.
my case, it's the wife factor because they actually they have a name for it. It's like the wife approval rate or something like that because you install all these systems and then you need to tell your wife, okay, so now you need
Uh,
to use it and don't use that button to turn off the light because then I can't turn it on again with my application or something. And that's difficult because for example the lights I'm using, they're still connected to the main switch I have, and I can turn them off with my application and with my system. But of
mhm,
course, if my wife turns off the light with the main switch, I can't turn it on
mhm,
again
mhm.
with my application. So I had to tell her, don't use the main switch, and of course that doesn't work.
You need another smart device to control your wife, messing with the switches.
Yeah,
You need
exactly.
more. When you get a problem, you gotta get a new smart home device, uh, like some robotic hand that will catch her and like put her hand on another switch or something.
Yeah,
We need
maybe
we need
that's a
more
good.
complexity. And,
Maybe we need to think
and,
about that.
and, 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 and use 15 neural networks there. 15
Sorry?
like and use like 15 neural networks there, that's like
Definitely,
really
at least.
computationally expensive. Yeah,
Yeah.
track her emotions, her face, her like the liveliness of like her face, that it's like real, that it's not a recording or something. Then like the I don't know, like what else can you do, like her I don't know, clothes, whatever, but
Yeah,
more neural
way over
networks.
engineer everything.
Yes, like that's how we make progress. we, we just build up more complexity.
Exactly, exactly. Well, what I did, I bought a Wi-Fi switch, and I told her to use a Wi-Fi switch because then it will send the Wi-Fi switch will just connect to my API and use the API to turn off the light. So now I have like four switches for a single light. I think
So
doesn't
so when
work as
so
well.
when you kind of use it so that you can, I guess, turn on and off your lights like from your phone, and also there are some motion trackers you've mentioned, right?
Yeah, yeah. I use the motion trackers. I use yeah my phone. I also have an Alexa integration,
Mm-hmm.
the Amazon Alexa, things like that. I really like it, but yeah, the usability should be improved in order for my
Mm-hmm.
wife to use it as well.
And what if like you use trackers and then you like read a book and you stay like in the same pose for like a long time? Do lights go out? Do they like go black, or how does?
You mean like to track your location within your house?
I mean like the way I'm kind of seeing that is you have motion trackers that track your movement, and when you kind of move around your house, lights are on, and when you don't, they're off.
Yeah, exactly. But of course, I don't have it everywhere because in the
Okay.
living, I don't want it to turn off when I'm just sitting and not moving.
Hmm.
So here I don't use motion in the living. I don't use motion
Hmm.
trackers. Only like when you go to the toilet, you go to the to my storage room and so on. That's all fully automated by motion tracking. But maybe I was
Yeah.
thinking I can use some infrared sensors to see if someone is present. So instead of looking at motion, just looking at presence. That
I,
might
I,
that might work.
I've been playing around with object detectors. You can get a GPU and put a camera and process frames in real time, and then see if it detects people in the frame. Think about
That's a
it.
good
You
idea. Yeah,
need neural networks. Go complex. Don't go with just
but
infrared.
again, also there you can you need a camera in your living room.
Yeah.
And I tried it before, but my wife she didn't like it because she felt I was always watching her when she was in the living and I was at work or something. So yeah, she took them away.
Well,
Again, the biggest complexity in IoT systems, in home IoT system, is really the wife approval rate,
yeah.
the WAR factor.
Yeah. Once that's once like that's taken care of, like then then we go back to the next
Exactly. Yeah.
IoT level. Yeah,
That's
I
a
get
whole
that.
next level of innovation. Once you reach that goal.
Yeah, like literally next week humans are landing on Mars and like on what Mars on Pluto,
Yeah, we
and like
just
set up
colonize
the
all the
base.
planets after
Yeah,
that.
and put all smart devices like all over the solar systems. That now we can know when it's like hotter than usual on Jupiter, and when the rings start to rotate a little faster on
Yeah,
Saturn's. That's
exactly.
a lot of useful information there.
But
Yeah,
first solve the wife factor.
yeah. I mean, what do you think about like privacy when it comes to Internet of Things? Because like it's a huge factor in the wife approval thingy, but like it's also kind of what concerns people.
Yeah,
But
yeah, I hear that a lot.
Mhm.
It's difficult because we now have in Europe this very, let's say, tough legislation with regards to privacy. It's called the GDPR law, which is pretty cool because they're doing a lot for our privacy. But what I feel, I think it's now been put into place since a couple of months, and what happens is that now just every website that we visit just has a pop-up that says if you want to visit it, if you want to look at the
Mhm.
content of this website, you first need to approve that we store your personal information, that we track you using cookies or something,
Yeah,
and
I
yeah,
see this a lot
everyone
too.
just approves, and they want the content, they want this instant reward, so they just ignore their privacy and approve. So it's a very tough thing to solve, I think, and definitely with regards to IoT.
Mhm.
Um, but I don't have an answer to that. It's a difficult. It's really
Mhm.
difficult. For example, what I saw with the camera that I bought for that I had here in the living room, the one I just
Yeah,
talked to you about,
yeah.
um, that one I bought it from a Chinese web store, and after installing it, I looked at my network configuration and I saw that the camera automatically opened like 100 ports on my router and was
Mhm.
sending information outside of my home network, so probably to their servers or something. The security, the protection to use my camera feed it was very easy to get in. It was like default admin password and username. So anyone could actually just look at my living from anywhere, and that's really
Mhm.
frightening me. And I don't know how to solve it. You probably The companies need to be responsible. You yourself need to be responsible at some part. You really need to be aware of what data you're sharing. It's a difficult question.
Yeah, I've read the book. It was called Big Data some while ago, maybe like half a year, and they were saying that the they were saying basically two things, and the first one was that privacy will kind of like go away. I mean, it's not like it's not the. I mean, it'll just be kind of much harder, and it already is much harder to stay, just super private because you
Yeah,
live
yeah,
the data all over the place. And they were like giving some examples that there were some data sets or something like that, not open, probably like even commercial or something, but they were made public, and you could basically track the people down from those data sets. Maybe not all of them, maybe it's like some of them by knowing some criteria from there, probably like comparing to other places where you could get the info.
yeah, yeah,
Yeah.
yeah.
And the second thing that they were saying that there will be like some new emergent sort of like lawyer professions, sort of like lawyers who also dig in big in like data science and AI and
Definitely.
IoT,
Yeah.
that will kind of help both the businesses to not violate the privacy and like stay out of trouble, and help customers to kind of
Yeah.
protect their privacy.
Exactly, and that's what you see here in Belgium. There are a lot of law firms really
Hmm.
jumping on that and trying to, uh, let's say, yeah, specialize in privacy and so on, and that's a good thing, of course, because since we have this European legislation, privacy legislation in place, a lot of companies have questions and they actually don't know what they need to do in order to guarantee the privacy of their customers, um, and 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 lawyers are helping them, for example, uh, with
Hmm.
looking at what measures they need to put in place, how they need to protect the data of their customers, like things like that. Yeah.
Yeah, yeah, but I guess it's not like really your main area of expertise, and you're more like on the technical side of actually making it possible first, so that we can even really, I don't know, try to solve it then.
Yeah, exactly. You need to pick your battles, and my battle is technology,
Yeah.
and I'm enjoying
Yes.
that one.
Yes.
And privacy is a way other battle and a big one.
Yeah. 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 Makes sense. Yeah. So, and another thing that I've spotted while like reading your paper, that you were using a lot of simulations to and
Yeah.
just to be like honest, I didn't read them like cover to cover. I read the abstracts and kind of try to understand what was going on there. Just to be clear, I'm not like imposing that I
Yeah.
went and read 8 papers overnight. Yeah,
Yeah.
so you were doing a lot of simulations to kind of predict how would IoT systems, how would they function on like a bigger scale? Yeah.
Yeah, exactly. Because that's a problem if you want to test decentralized IoT systems and give them adaptive behavior
Hmm.
at a larger scale. It is, of course, very hard to deploy these systems yourself. It will be, yeah, you need thousands of devices connected to each other. If you do this in a real life environment, it will cost you a lot of money. And you're just trying to test an algorithm, for example. You don't have a proper use case, probably. You're just trying to see what can I do, how can I optimize traffic flow, how can I uh, build an algorithm to let devices connect with each other, talk to each other. So of course, a simulation environment is much easier,
Hmm.
um, and that's what I'm looking at looking how can we use simulation to test
Hmm.
and calibrate various algorithms that we can develop on top of on top of IoT systems.
And what like happens inside of the simulation? Like, could you, I mean, maybe give an example of an algorithm, and then how simulation goes about, trying to see how that would work?
Yeah, so the example I always give, and it's probably an easy one, is again
Mm-hmm.
the one with the traffic use
Mm-hmm.
case where we have smart traffic lights that can that really have the ability to sense the traffic, the local traffic in front of them. And on the other hand, we have this the traffic itself in the city, and if we want to optimize traffic flow by using these smart traffic lights, we will need a simulated environment where we try to simulate actual traffic in a city context, and then deploy these virtual smart traffic lights in this simulated environment and see how they can cooperate. So we're seeing how we can deploy algorithms on top of these
Okay.
smart traffic lights to see is the traffic actually going, is the traffic flow actually improving. So that's an example I always use, and I think
So
um,
so it's kind of like somebody like walks in the room and says like, hey, I've just invented the like genius algorithm to do the IoT traffic lights that will like that will help the traffic move faster and like save time. And then I mean, of course, you can just go and like put it in the street for a day. Like, let's see, like maybe if there's like less than 10 accidents that'll happen, like that's safe. And like if there's like more than 12, yeah, like we'll put it off for later. And that's
yeah,
kind of
yeah,
where you come into the game and help kind of simulate.
yeah,
Yeah,
exactly. And of course,
uh-huh.
I'm also involved partly in we're setting up a research trajectory where we look at how can we train these algorithms automatically,
Mhm.
and then we're looking at multi-agent reinforcement learning,
Mhm.
where we consider the IoT environment to
Mhm.
be a partially observable uh, environment, and try to act on that, and really there the smart traffic lights are agents, and we try to
Mhm.
look at how can we teach these agents to automatically work together by sensing the traffic they can observe. Um, so that's
So,
another
uh-huh.
use case we're trying to build.
Mhm.
But it's very difficult because, of course, reinforcement learning itself is
Mhm.
already difficult, and we try to, and even in these really, let's say, easy environments,
Mhm.
it's already hard to build a very well performing algorithm. And now we want to deploy this into a very difficult, non-deterministic environment
Mhm.
where you need a model of the environment at all time in order to really take some useful actions.
So with reinforcement learning, I mean, when I kind of think about it, it's like solving video games. No, I mean solving like video games like the AlphaGo and Dota 2
Yeah, yeah,
from
yeah.
OpenAI. And then in this case, the environment is your simulation of traffic, and the agents are traffic lights. Yeah,
Yeah, correct. Yeah.
and those agents, is it like deep reinforcement learning or what is that?
Yeah, well, there is this. What we're looking at in this context is not only to fully solve the problem because it's a very hard one.
Yeah.
It again, every agent, every traffic light can only observe part of the environment, so it doesn't have all the information, and also the rewards are sparse. You don't have a direct reward as you have in a video game, for example. So it's really complex. And on the other hand, we want these agents, these traffic lights, to work together and interact with
Mhm.
each other in order to solve it. And there are all these kind of techniques like deep Q learning and so
Mhm.
on. But for now, we're trying to just start with a very basic example, and look at how can we just make it possible that these agents interact with each other and communicate with each other, and that already is very difficult. So we have this big vision
Mhm.
going towards the future where we can maybe solve such a system using reinforcement learning. But we want to go there step by step, and now a colleague of mine is really looking at how can we use communication to improve a global reward, and in this use case, the global reward would be traffic throughput in a city. So and that's I think where Internet of Things and AI can really come together. Of course, you already have a lot of AI in the context of Internet of Things, but then mainly related to data processing and trying to act based on predictions. But now I think we can really look at an IoT system as a complex environment and look at IoT devices itself as smart agents. And if we bring all of this together, we can maybe optimize global emergent behavior. And that's really a big vision. I think the big vision that we have in our research group, and we're trying to see how far we can get there. But it's difficult. It's a lot of work we still need to do. It's very interesting, of course.
Okay, and what makes it difficult? Because I mean, like think of like if you think like a lot of cars, you can like predict how exactly they'll move, and like a lot of traffic lights, like weather and all those factors. But what makes it difficult? You know?
Well, there's a lot of things we still need to solve. Like I said, we need to allow agents to communicate with each other and collaborate with each other to solve a single goal. That already is very difficult. Then we need these agents to be able to observe an environment that is not fully predictable and really build an internal model of this environment. But of course, the agent also needs some intuition of how this environment might evolve. What are the physics of the environment? And again, it's only every agent only has a part of the entire picture. An agent will never have the full information of the entire environment, and they need to communicate with each other in order to share information, and that's really very, very difficult, I think. So we will see how far we get with it, but all the challenges I just said, they're state-of-the-art research, and I think DeepMind published a very interesting paper with regards to communicating and reinforcement learning. And there is some progress, but it's mainly on small use cases, not very complex environments. And I think this is really the big goal, to go towards a system that can combine all these challenges together, and maybe then we can solve it. But we're not there yet, so we need to see. Again, pick your battles, and there we have the communication battle, we have the partially observable battle, we have how are you going to formulate a reward? How will the agents be able to have an internal model of the environment? And so it's very interesting, and I like it. And again, that's why we need simulation as well, to test and simulate what is possible before we move to an actual real world environment.
Yeah, I think what may be encouraging, because while you were talking, it really reminded me. Have you followed OpenAI and their like Dora 2.5? The
I heard about it. It was interesting. Yeah.
I actually used to play Dota like something like 2 years ago, so it kind of really caught my eye. And all the things that you've mentioned, like the limited information and like the teamwork and the complexities, like they all are, you know, a really huge part of the game. You like, you don't know what's going on there. You may not like see where your enemies are. You may not know, like, there are so many like spells and items and like so many directions you can go in. So and
but
they
I think with OpenAI they already had the full information of the game. They like cheated a little. I think they already had an entire. I'm not sure. So I don't know if you know, but I thought that they already knew where the enemies were located and so on. But then
No,
still, they need to collaborate. And
um, I actually don't. I don't think they should have. I mean, in the training, I guess they simulated and ran a bunch of games, but like the way Dota works is that you see where your teammates are, and you know where your teammates are, but you can only see your enemies if they're in your kind of circle of vision, if they're close to you, if you can like see them. And if they're like on the other part of the map, you cannot just see them.
yeah, I'm not 100% sure, but of course,
Mhm.
if they already are able to do to get proper results,
Mhm.
um, while they're using the full information of the game, then already I think it's an incredible achievement, because they need 5 agents that
No,
work together and
no,
specialize. And
I actually think they weren't using the. I actually think they were using like the human level information. I think there's like a bot API of from Valve that kind of tells the bots, but they should not have known more than a regular player would have known. Plus, they had like restriction that the bots weren't allowed to use illusions or replicas. It's like when there is multiple characters that you control, like say not one
yeah,
hero but like five, and it would have been unfair because a computer may just play five characters like really easily, and for a human player it's not possible. And with that information,
true, true.
they were able to like give a really good fight to the pro teams. Yeah, they were actually crushing their opponents up to the international, like the biggest championship of
Well,
Dota. Yeah, and then
it's
they
really impressive. Yeah.
yeah, and then they were playing against the pro teams, and the average Dota span of the game is like 45 minutes, and almost all of the games against bots were 60 minutes, and bots lost eventually, but like that was interesting. I haven't followed Dota like for 2 years and was like over it, but I got excited to see that.
Yeah,
and
yeah,
and yeah, and if like that kind of progress is possible, it gives a lot of encouragement. I think that's a part of
definitely.
OpenAI mission to kind of not just solve video games, but kind of learn the techniques that it takes to create something that can operate with all those complexities and the limited information,
Yeah.
and then kind of translate that, then put that into some real world uses.
Yeah, because I think video games are great to do that. They can easily go from fully observable
Mm-hmm.
environments with a very direct reward,
Mm-hmm.
and try to increase the complexity, go to more complex environments like, let's say, AlphaGo or
Mm-hmm.
Dota.
Yeah.
And if we go to a situation where the algorithms are performing well in these very complex game environments, probably they will also be able to do that in a real world environment.
Yeah.
And it's easy. It's very easy to test in these games. There are simulations,
Mm-hmm.
and
Yeah.
you have
Technically,
a
they are.
direct feedback available.
And I wonder what happens with traffic, like in your simulations. Like, what are the like parameters? Like, how could you like try to visualize that maybe, or like paint a picture of it?
Um, so you mean what of the traffic behavior,
Yeah,
or?
yeah, of the traffic. Let's say, yeah, for
Yeah,
example,
so
that.
again, there we use very basic traffic behavior. So I'm looking at making it more complex, but we have a distribution of speeds, let's say,
Mm-hmm.
where we try to, based on this distribution, these cars will drive around. They will try to avoid colliding, of course. They will stop before the traffic light. And it depends. You have areas where people will drive faster, areas
Mm-hmm.
where they will drive slower. But it's not our goal to go towards a fully realistic micro traffic simulation, because there's a lot of research
Yeah.
already, and there are a lot of simulators available. But really, it's our goal to look at how can we facilitate the simulation of these virtual cars at a very large scale. So how can we look at simulating, instead of 1,000 cars, maybe 100,000 cars
Mm-hmm.
at the same time? And that's the main challenge I'm looking at right now, and we use there various techniques to really come towards realistic behavior, but also taking the computational complexity into account. So it's a trade-off between optimizing for scale and optimizing for accuracy.
Yeah, actually, I like the way you respond to the question, because I was going to ask how computationally expensive, like the whole operation is, and how you compromise that, and like you went on and answered that.
Yeah.
So now I don't have a question yet, but I'll have one. I'll have one in 2 seconds. Yeah,
Great.
and uh, okay, that was three. Fine, but and how do the cars behave? I guess like, do you program? So I mean, does the car just go in a straight line, and then there are like other cars, kind of after it,
Yeah,
and
so well, what I did, I parsed OpenStreetMap. You know
mm,
OpenStreetMap? It's like an open source street data, and they have like all the geometric data of streets, and I use that, and then I interpolate between the various coordinates on these streets, and then I let the cars just drive on it, given a certain speed. They can observe the agents that are nearby, and there are various ways to simulate them. You can just let them drive around and update each
mhm,
at a fixed time step interval. You can update the position, like for example 20 times per second or something.
mhm,
But on the other hand, there are other simulation formalisms where you instead try to look at, okay, I'm now at this location. I'm driving at an average speed of 50 kilometers per hour. Um, I will end up um, at another location in about 20 seconds or something.
mhm,
And instead of updating the position of the car every time, it will just update the position when he arrives at the next
mhm.
destination. That's another way, and that will be much less computationally expensive. And we're trying to dynamically switch between these formalisms to dynamically optimize the computational cost of the entire simulation. Um,
And,
but so
and what kind of a machine does it take to run the simulation now? Like what? Uh-huh.
so we look at currently I think I'm able to run like 30,000 agents on a single PC, like a regular desktop
Okay,
PC.
sorry, how many?
30,000.
13,000. Yeah.
30,
On
yeah.
30. Okay.
30,
Uh,
yeah.
uh-huh.
But that's on a single machine in a time-tapped fashion, where you just update every
Mhm,
20 times per second, so I can run 30,000 at the same time. But we're looking allez, I'm now building a distributed simulator, so using multiple cloud
mhm,
nodes at once to simulate a single simulation.
mhm,
And then we can probably scale up to over 100,000, maybe more.
mhm,
But again, of course, it depends on what accuracy that you need, because if you don't need a lot of accuracy, you can easily scale up to
mhm,
maybe 1 billion or 2 million devices. It all depends on how accurate you want to simulate. You probably can aggregate some areas instead of simulating the position of the car at every time step. Maybe we just say we have on average 100 cars coming in each hour and 200 cars going out of the area. So we're also looking at how can we combine time-step simulation with a more abstract representation of the simulation, and then you can
mhm,
just using statistics you can try to predict accurate behavior, accurate car driving behavior in a
mhm.
given area. So that's
And so you
another
can all
approach.
and you can also try to evaluate the performance of
Yeah,
various
yeah, of course, because you will
algorithms.
lose accuracy then.
And I mean, and I wonder, like if the algorithm isn't good, like what happens? Like, do cars start bumping into each other, or like, I mean, kind of virtual, or like what happens?
Yeah, I had some times that I generated too much traffic in the city, and I had a deadlock. So all cars were just stuck in the city, and nothing was moving.
So it's like there's like nowhere to go, and like all the space is filled up with cars.
All the spaces was filled up. Yeah.
It's time to go in the third dimension. Cars. It's time to like build a ladder out of cars for them to like start
Yeah.
evolving in their car
I can
world.
include that in the future. Yeah, it would be fun to see
Yeah,
what they do.
and like then break out of the simulation and take over the human world.
Yeah. If we believe Elon Musk, then it's
Yeah,
possible. Huh?
yeah,
They will become intelligent inside of my simulation, and
yeah. Those cars will not be happy. You put them in that
yeah,
environment.
probably not. But if
Yeah.
they come to the real world, there's also a lot of traffic in my city. So actually, it's a very realistic representation.
So they'll be like, okay, like at least that guy was kind of telling us the truth about the world. It isn't much better. Yeah.
Yeah.
Have you seen, by the way, like about Elon Musk, and have you seen the demo of the Boring Company? They've opened the first tunnel.
Not yet. I heard about it that they opened a tunnel or something.
Yeah, yeah. I can
But
show you my screen and
okay,
just
cool.
here I was googling what POC meant. I didn't know what POC meant. I was like, what? It's
Okay,
so
yeah, yeah.
weird.
That...
I should have closed that
Yeah,
tab, but like, who cares? Uh, I mean,
exactly.
yeah, I've watched the YouTube video, and yeah, I mean, I think they went like 110 miles underground. Yeah, and how do you
What?
think? I think the car, yeah, that's the tunnel, and it
Yeah,
was
yeah,
like
yeah.
there's the tunnel, and the car comes in, and then Elon Musk walks
Yeah,
out
yeah,
of the
yeah.
car with some guy, and started telling the presentations, and like from your experience with traffic, how what do you think about the transportation going like 3D, and
Yeah,
like
I think of course, I'm not a traffic expert. I
yeah.
just build simulators, but I think it's an incredible idea. I remember
Yeah.
seeing the tweet of Elon like 1 year ago or something that he said, I'm bored of being stuck in traffic here in LA. Let's build a tunnel." And he's
Yeah.
actually doing it. So I wonder how it will work. I wonder if it's practical, because I guess it will cost a lot of money. But I guess they have proper equipment to build these tunnels, given the fact that he's doing a lot of work with the train tunnel thing, the magnetic train. Uh,
Hmm. Yeah,
so
it's kind of how it.
yeah,
But the
it's
magnetic train.
interesting.
You mean like the kind of train that they have in China when like or like the hyperloop. You mean like the hyperloop when
The
it's like
hyperloop. Yeah, yeah,
yeah
that was the
the
name.
the
Yeah.
vacuum tube that transports you like in some crazy speeds. Can you see the
Yeah,
video?
yeah. Sorry?
Can you see the video?
Yeah, I can see it. I can see
Yeah,
it. It
good.
looks cool.
Yeah. I mean, and I think they're actually trying to make tunnels cheaper. So, and they're trying to beat the snail. I don't know if you kind of heard about it. They have like a snail in the Boring Company. And by the way, like it's a cool name. It's a funny
Snail.
name.
Yeah.
Yeah, they have like a snail. I think it's like the sixth snail Elon mentioned in the presentation. Because like snails don't live that long, so it's kind of like the sixth snail. It's named Gary, and they're basically trying to be able to bore tunnels faster than a snail can walk. And right now
Okay. Yeah,
the
yeah,
state
yeah.
of the art technology is like 14 times slower. Oh,
Wow.
I think oh oh this thing I think is the tower that was built out of the dirt bricks. They kind of dig the
Wow, they
tunnels.
built out of the dirt that they dig up.
Yeah, they
That's cool.
yeah, I was watching the presentation. So they take the dirt out of the tunnel, they press it to form bricks, and they've built the tower, and I think they're gonna sell it, and they've mentioned that it may even like cover all the costs. And I think what was cool, they also said that if someone like needs bricks and they're in some condition, something like in need, they can just give them the bricks for free. Yeah,
Yeah.
I think that's awesome.
Yeah, I
Yeah.
really wonder if they can make it cheap to dig these tunnels, because of course that will be the main challenge.
Yeah, it's it's probably still will be like more expensive than just walk. I mean, of course, but
Yeah.
I mean, I think they can drive costs down. I think that Elon and his team, they like they're smart and they work like crazy. So I don't know. After all the stuff that we've seen from them, I wouldn't be surprised. I don't know like if it's a good or a bad thing because you kind of get used to it.
Yeah,
Yeah.
well, I thought it was crazy at first, but
Yeah.
well,
Oh,
they seem they
and
did
they
it.
s- yeah, and they sold those flamethrowers.
I
Have,
saw, but you can
have you
only
heard?
buy them, I think, if you live in the US, because otherwise it was only $700 or something, yeah, for the
Yeah, that
flamethrower.
was expensive. I
Yeah.
mean, and I think that the point thing that you can't legally ship flamethrowers to other countries, so they named them like this. They named it not a flamethrower.
No
So
way.
yes, look at that.
Not a
Not a
flamethrower.
flamethrower. You can like, go and buy not a flamethrower. You can ship not a flamethrowers.
It's
That's
crazy.
legal.
It's crazy.
Yeah. So and I
Not a
think
flamethrower.
yeah,
Yeah.
yeah. I
But this
think they
is like really working?
I don't think it's like the military kind of flamethrower,
Yeah, I
but
guess so.
but
Not a
I think
not a
it does.
flamethrower.
It does. I think you can like make fire with it.
Yeah.
Just here's some videos. Um, I think they raised like $1 million selling the burning company hats, and then they raised like $10 million selling the flamethrowers.
Yeah. That's awesome.
Yeah, it's super exciting to see what they're doing with transportation.
You can you
Oh,
can
look
bake
at that.
meat with it. That's a use case.
Yeah. Yeah, it's like it's in Siberia. In Siberia, that would be useful. Kind of go home like in your long walk in the cold winter, and you like get hungry, so you just get the piece of meat out of your pocket and just start frying it just on the go with like flamethrower. Yeah, yeah. I
Yeah.
think yeah.
That,
I've listened to the interview of Musk on the Joe Rogan podcast, and he said like it wasn't that more complex than just the whatever that thing is called in English, where you just have like the gas in the cannon that kind of just
yeah.
spits fire. I don't know what it's called, but yeah, it's cool.
Yeah, definitely.
And and,
It's
and
smart. It's like
yeah,
he probably got the attention he wanted,
yeah.
and actually, how much money did they collect with it?
I think $10 million from
10
flamethrower.
million. Yeah, well,
Yeah, and I
gives you
mean,
some.
yeah, and that would be just hype and like nothing, but they actually build tunnels, so it's like triple cool.
Yeah.
Let so it's actually funny. The name is funny, like the Boring Company, but it turns out to not be boring. But they are boring tunnels, but they're not boring. Those names. Oh
The boring company.
yeah. So okay, I'll cut the screen share now. Yeah.
Yeah.
So
Cool.
yeah, I like following those guys, like the people that work real hard. Yeah. So what are like the other things that excite you when it comes to I don't know life, what you're doing?
Well, I just like beer.
Okay.
I was thinking aside from AI programming and these things, yeah, I like to go to bars and just have Belgian beer. Don't know if
Sure.
you know Belgian beer, but that's what we're
Yeah, I've,
famous
ac- I've,
for.
ac-
So
I've actually heard maybe on some
yeah,
YouTube videos about Belgian beer. Oh, I think I've listened to. I think that was Have you heard about the How I Built This podcast with Guy Raz?
no,
It's the same
never heard
guy
of it.
that does TED Radio Hour. Have you heard about that podcast?
No, no, it doesn't
Uh,
ring a bell.
ah, anyway, and there was like some American beer brewing company, founder, and he said
Right.
that he got inspired from Belgian beer and started brewing that in the US. And yeah, and then so yeah, Belgian beers, that's what I heard him. And then
Cool.
kind of the whole thing took off, I guess.
Yeah, yeah. Belgian beers. It seems to be a big brand in US as well. Mainly because now they have all these like small brewing companies,
Mhm.
um, and yeah, we have tons of beers here in Belgium, um, all locally brewed, and yeah, just it's cool. I like it.
Yeah.
Actually, my promoter he has its own like small brewery and he makes his own beer. Now he has a second daughter and he will have a special daughter beer for
Sorry, what beer?
for his he will have a second daughter, I think. His wife is pregnant, and to
Okay.
celebrate it, he's now brewing a daughter beer. So to celebrate the
Oh,
birth of his upcoming daughter.
is it like a common thing in Belgium to brew beer?
Well, actually, I know quite a lot of people that brew beer, so it seems so. Yeah.
I mean, in Russia, uh, just kind of watching my father maybe a bit, and something like that. People aren't brewing beer, but they're brewing something that's called in Russian samagonka, and that's basically
Tomagonka.
it's basically what you brew that's not beer, but it's not even anything, but it's like it has alcohol, you can drink it. That's kind of what I heard of. Yeah, I guess depending on your style, you can make it not. I've never actually like tasted that thing, but
Really?
yeah,
And it is like beer, or is it more like vodka or something?
I think it's more like some substance that just has alcohol in it, and for as long as
Yeah.
it has alcohol in it, it works. So people do that. I mean, probably you can make something good out of it.
Yeah.
I
The
don't know.
Siberian way.
I don't know if I could like Google the definition of that in Wikipedia. Okay, I'll Google the Russian definition. Oh, I mean, there's actually the English one. So let me just show you. Okay, okay. So that's like the Russian thing, and it's like the
A
I think it's called.
moonshine. Yeah, yeah, yeah.
You
Yeah,
heard
I've
about
heard
it?
of it. Yeah. It's like, yeah, people brew it themselves.
Look at this guy. He's so happy.
Moonshine. Yeah, it's like a really strong liquor.
Yeah, Braga is written here.
Isn't it similar to vodka? Like vodka that you just brew on your own?
I don't honestly know, but I guess and it's written here that it's a high alcohol. It's got a lot of alcohol drink. It's made in the home conditions. Uh, yeah, I mean,
Yeah, yeah.
I,
I think
I think it comes like from like the Soviet Union. You probably couldn't have buy much drinks. Although I guess you could, but it was expensive or something. People were just
yeah.
were just hustling and doing the best they could, and
Yeah.
still do. Yeah, but like I don't know. I'm actually 17, and I'm below even the like I'm gonna be 18 soon. But like I'm below the drinking age even here.
What
So
is the drinking age in Russia?
18, but
Eighteen.
I mean it's more like 12 if you really wanna. I mean, of course not. But like, it's. I mean, yeah. I mean, the illegal one is 18, and I'm not a like huge fan of drinking, especially like below the legal age. But
Right.
it's more like I know people who don't have problem getting drinks, and I tried some non-heavy stuff, but it's I mean you won't go to jail if you. uh, it's more like it's possible to get drinks here below the legal age, I guess, just like in any other part of the world.
Yeah.
Yeah.
I guess in the US they're quite strict on drinking age, stricter than in Europe at least, I think.
Hmm.
Um, but I don't know, yeah, about Russia. Here the
Yeah.
drinking age is it's I guess it's 16 or something. So
Hmm.
if you come to Belgium, you can already
It's
drink a
16
beer.
here.
Yeah, I
Seriously?
think it is.
Oh my
Yeah.
god, I didn't know that.
but
Is
but then
it the same? Is it the same in Germany or in other
yeah, I
European?
think in Germany it's also 16 for the beers. Eh? If you wanna have liquors, then I think you need to be 18.
I'm gonna Google that. It's so crazy. Drinking age. I'm gonna show you the screen so that you aren't too bored with me typing. Oh yeah, that's actually 16. And I mean, and Russian is, yeah, it says
16. Yeah.
here that Russia, but in Germany it's 16. Oh, I mean that's quite crazy. But I mean they wouldn't sell you like the heavy stuff. It's more like beer or something like that.
Yeah, it's beer and below 5% or something, or below 10.
Yeah,
Maybe wine as well. But
yeah,
but the heavy
uh-huh.
stuff like over 15 or 20%, that then you need to be 18.
Yeah. It's actually quite normal here. If it's like a New Year celebration, um, if you're like 14, 15, 16. I mean, my parents usually give me. I don't know if I can like say that on the record, but like let's say that they kind of allegedly give me a glass of champagne, just a small one, just for a new year. Like it's not a problem here.
Yeah,
That kind of thing.
yeah,
Yeah.
it's the same here.
I like the way the podcast starts with simulations and AI and the Internet of Things goes into beer. And
Yeah,
even more like in Russian samagonka. Yeah, that has something to it.
yeah, it moved quickly.
Huh. How can Internet of Things be applied to the drinking industry?
Yeah, I
Your
think in a
thoughts?
lot of use cases, automate the brewing process and uh,
Yeah. Can it be like can it be like you drink and it kind of senses that you've had too much and then it automatically calls a taxi or something
yeah, probably on
and
your
Uber.
if it automatically like takes a blood sample or something, or
What's
or
up?
smells your breath.
Oh my god! I can almost see that a robot like a robot or like a glass kind of gets the needle and like gets your blood sample like ugh, and then it checks your blood and then it checks your blood every 10 minutes or so
10 minutes
like
or something, like a big stick.
welcome to the bright future where your glass will be putting the needles into your body every 10 minutes.
Yeah, I don't know if it will sell, but
Oh, yeah.
who knows?
Who knows? I mean, I think they do that in like I think there's like the needle therapy where or something like that. I don't know how it's called, but when people like put needles in themselves, it's like in the movies sometimes, and it's kind of
Yeah,
like some Chinese or Eastern thing or something like that. Yeah, there's a lot. There's a lot of
interesting.
there's like the takeaway here is that there's a lot of potential when it comes to the Internet of Things.
Yeah, exactly.
Yeah. So I don't know. I actually don't know. Maybe you have like a funny story uh, from like your Belgian beer or something, and then we can like go back to other topics. I
Okay.
just feel like I just feel that'd be cool to like a
Yeah,
story.
yeah. So if you're asking for a funny story.
Yeah,
Um,
maybe we had like something funny happen.
well, that's with regards to beer.
I don't know to anything.
Yeah. Uh, well, yeah, it's a difficult one. I don't know by heart something.
Okay,
Sorry.
okay, no problem. So I don't even know where to go after beer and Samagonka and all that stuff. But School of AI, you host meetups for School of AI, or you do
Yeah,
something
yeah.
with it in
So
Antwerp?
we started with School of AI, I think about 2 months ago or something,
Okay.
here in Antwerp. So we hosted our first session together with the university and some companies in the city, and it was pretty cool. We had a lot of people were interested. I think about 200 attendees or something, and
The,
even
so, so,
Siraj called in.
sorry, 200, what?
Attendees, 200 people that
Ah,
came.
attendees. Okay, okay, yeah, I see.
Yeah,
100 people who came to the meetup, yeah?
yeah, to the opening event the first
To
time.
the opening event, yeah.
Yeah.
And you were helping to organize that one, yeah?
Yeah. So we hosted that one at our university, and then last week or 2 weeks ago, we had our second event, which was about reinforcement learning. An introduction to reinforcement learning was really cool. It was
Mhm,
again a lot of interested people, a lot of interesting people also.
mhm,
Yeah, it was nice. So I'm looking forward. We will have sessions every month,
mhm,
um, and a lot of cool topics coming up. I'm working on preparing a session about understanding the math
mhm,
behind neural networks. So
mhm.
I'm working on preparing some Jupyter notebooks and then do a small presentation about how you can build a neural network from scratch and understand the derivatives and so on,
Mhm.
the linear algebra that
and
you need to
and that'll
understand.
be about some specific neural network architecture or like in general.
Yeah, I wanna start with regular
Feed
solving
forward.
MNIST with a softmax
Mhm.
activation and cross entropy
Yeah.
loss, for example, and then I wanna build towards explaining the math behind CNNs. So
Oh,
yeah.
will you be doing some sort of webcast? Because I feel like I gotta brush. I,
Yeah,
I,
maybe
I'm serious. I mean, I get the math behind the feed forward neural networks, but when it comes to CNNs, I only know like the basic mechanics. I haven't really, solved through the math there. That'd be
Yeah, of
cool.
course. It would be interesting. Maybe we can record the session and put it on
Yeah,
YouTube or something.
I think that's useful content, especially if you're
Yeah.
like taking your time to prepare all the material. Yeah.
Yeah, exactly. Yeah. We should do it. Definitely. I had some questions from other friends as well who couldn't join some sessions. So,
Mhm.
yeah, will
A-
be cool to share it.
And who was the guy who said that? Like, let's organize School of AI at our university in Antwerp.
Well, it was I decided to do that.
Ah, that was you.
Yeah, yeah.
Yeah, you were the enthusiast behind that. Yeah.
Exactly. I'm the enthusiast. Yeah. So.
A- a- And you probably asked your coworkers, other researchers, fellow researchers to help. And what was like their reaction? Did they know about School of AI, Siraj's channel, maybe, or
Some of them had heard about it, but they I think most of them knew Siraj. I
Siraj? Yeah.
mean, if you're a bit interested in AI and you're on YouTube, you
Yeah.
probably see Siraj. So,
Yeah.
so they knew about him, and we already tried to do something similar before School of AI.
Mhm,
Set up regular sessions with people that are interested in learning about AI and sharing their knowledge. So we did that. We organized some sessions on YouTube. But it was always difficult to find people that were interested in attending and interested in also
Uh-huh.
organizing sessions.
Like in common to like a real life event, like
Yeah,
that's like
yeah,
physical,
exactly.
yeah.
Yeah, like a physical. It was always physical event that we had, and then School of AI was a great excuse to try it again. But now we really had the
Mhm.
a formal way of organizing it, and it was backed by Siraj. Most people know him. Then I told it to my boss at the university. He was very interested. He wanted to help. He even sponsored the first event. So also the university was interested, and they wanted to help with facilitating uh, the the event and so on. So yeah.
Mhm. And
Yes.
the event takes place in the university in
Yeah,
in classes there, yeah.
yeah. We have
Mhm.
like a big audit. How do you say? Like a big room
Oh yeah, yeah.
where we
I
can.
get what you're saying, yeah.
Yeah. So yeah, it was like 300 places or something, and we could use it entirely. So it was great that they wanted to help us.
Hmm. So and how do you kind of and like so you say I want to start a school of AI meetup here at Antwerp University. You like go to your again like fellow coworkers and to the boss and ask around. They say yes, go do it. And what do you do then? Where do you go? Whom like do you ask about it?
Yeah, so it took some time. I told them they were all very interested and they wanted to help. So the first thing was, okay, well, what are we gonna do first? We want to do something big and make
Hmm.
sure that a lot of people will attend. And wow, there's a lot of traffic here. Sorry, I'm a bit
I can hear that.
distracted.
No
I don't know if
problem.
yeah,
No,
I
no,
guess so.
no problem.
Uh, but anyway, they were
They need the IoT traffic lights.
yeah, exactly. I think that's the problem. They're frustrated that they don't have it yet.
Yeah.
But anyway, yeah. So the first thing was to find the right speakers and
Mhm,
get them together in a single event. So we contacted AI specialized companies here in the city,
mhm.
and most of them were very interested to help us.
And
Um,
what kind of AI companies were this? Like, what were they doing?
So we had a company who was also applying AI on Internet of Things. Another one was more focused on building chatbots like natural language processing.
Mhm,
Another was also healthcare, also Johnson and Johnson, the big healthcare company, and those were the three that we contacted, and all three of them attended the event. So was really cool that they wanted to help us out directly.
Okay, so I just had to tell my little sister that I will go to jail if she doesn't go away. Just
How it
typical
worked. A bit dramatic,
typical
but
yeah, typical like big brother stuff. Yeah, so you were saying about the AI companies like Johnson and Johnson Healthcare.
yeah, yeah.
Mhm.
So
And by the way, what are they doing in healthcare? I'm just wondering. What are they?
um, so yeah, it's for example a use case they were interested in is discovering maybe
Mhm.
new cures like new yeah medicine that can help, and they use AI techniques to really
To
look at what
generate
might be promising.
those drugs, yeah, like those some
Yeah,
molecule
to
stuff.
look at the combination of various ingredients, let's say, and
Hmm.
I think trying to predict if it might be
Hmm.
might help on a certain disease or something. I think that's
So
the main context.
so they kind of get like so they look at the existing drugs like what they're made of and kind of their effects that they cause, and then they try to like show that to I don't know neural nets or whatever, like some data science analysis or what they're
Something
doing.
like that. Yeah, that's the main idea, and they have all of this historical data of profiles of certain medicine, of certain
Mm-hmm.
active ingredients, and I think they want to explore this huge set of data that they have to see if something
Mm-hmm.
might be interesting to look at. That's at least the main idea that I have. But I'm not a specialist in healthcare, so I'm not 100% sure.
Okay.
But that was the idea.
Oh, okay. Okay. I mean, that's cool. I
Yeah.
mean, maybe you've heard, maybe they've discovered some drugs that way.
Um, I'm not sure actually. I think it's still again a POC, a proof of concept.
Okay. Mhm.
So
But I guess like they're not out of business, so I guess there's gotta be something. Yeah.
yeah, well, I'm not sure what the results are. I should
Okay.
have.
So, okay, no worries. So you get like those speakers, and what happens then?
Um, so what happens? Can you repeat the question?
Sure. So you kind of get the speakers from all those different companies, and
Right. Yeah.
what do you tend to kind of keep organizing the event?
Yeah, so
Event.
I asked for topics that they wanted to talk about. They were free in that, and then try to just pick a date when everyone is available, and put it on the internet, put it on a meetup page, and hopefully people will attend. So luckily that happened.
And you said 200 people came, yeah?
Yeah, so 200, I think more than 200 told me how do you say they subscribed on
Mm-hmm.
Meetup, and I think about 150
Mm-hmm.
actually attended. We didn't count. So.
And I wonder how many like of those 150 people were students at Antwerp, and how many were just AI enthusiasts who were living nearby and decided
I
to
think
come.
it was a mix. It was
Mhm.
about 10-20% students, and the
Okay.
rest all
Oh,
enthusiasts.
okay.
So
Cool.
maybe a bit more students, maybe 30%, something like that. It was
Hmm.
a healthy mix between people that were professionals, people that were getting started, people that were studying AI, and so on. We also had people from physics. It's really a very broad spectrum of backgrounds, which is definitely very interesting.
Uh, and did you give a talk there, like some opening talk or you
Yeah, I
know?
give an opening talk, a short one about the vision that we have about
Mhm.
AI, really about what we want to do with School of AI. I think that was the main message that I give, and also told people that it was really that there's no excuse to if you're interested, you can get started. There are so many great resources available, great books that they can use. So really try to motivate them to get started.
And how did you articulate those goals of School of AI? No, what did
Well,
you tell them?
I think the main idea is that we want to bring people together at a
Mhm.
regular time, so monthly, and then just discuss a certain topic that is hot, or maybe a more fundamental topic like math techniques and so on,
Mhm.
and just have a really easygoing conversation, maybe a presentation, and
Mhm.
try to work together, like try to learn something.
Mhm.
So, like for example, the session we had last week, the reinforcement learning session, it was someone was working on reinforcement learning.
Mhm.
He just shared his knowledge, his learnings with us, and he prepared a short tutorial or
Mhm.
a short challenge, and then we started working on it. It was really cool. We had a 1 hour presentation, and then
And
some time for
and
hands-on
and and
experience.
that was last week, right?
Yeah, I think last
Okay.
last week or the week before. Yeah, the week before.
Okay.
So
Okay. And was it hard to kind of get registered on the School of AI like website, or kind of
no,
get accept easy? Yeah.
I just submitted the form,
Okay.
and I think 2 weeks later or something, I heard that
Mhm.
I was selected to be the dean of School of AI Antwerp.
Okay.
So,
And the word dean, what does it kind of implies that you're kind of that you're gonna help organize the events, you're gonna like organize them,
Yeah.
take care of like meetups and or like getting together like the local community. Yeah,
Yeah, so
I
taking the
uh
responsibility, yeah,
yeah.
to host these sessions and make sure that someone is really trying to motivate people
Mhm.
to prepare sessions, to get to think about what curriculum we will have, what kind of sessions we will organize, and get a mix in the topics so that we not always have reinforcement learning, but also cover maybe
Yeah,
GANs and object
okay,
detection. I don't know, something.
yeah. And like, what was like so far the most exciting thing that you've kind of experienced, maybe like in terms of like meeting people or like getting new ideas from there, or just the process of organizing School of AI and in the course of those events.
Yeah, I think it was really cool to see that so many people were interested. I really didn't expect that. When we tried to organize similar things a year or 2 years ago, we
Mhm.
had like two people, three people that turned up, and now suddenly we had more than 100. So that was great. There was a lot of enthusiasm. You really
Yeah.
see that there is a momentum and that people are interested in learning more and I think that's great. So we picked the right time to get started with School of AI.
Mhm.
Um,
Yeah, I think I've heard you there. I've been like at a local student conference, and the teacher who kind of, how do I say it, who kind of supervised my project there, he told me that like last year there was almost no one who was building something with AI, at least like in Novosibirsk. But now, like this time, there were like I don't know 50% of the people, maybe 40 to
wow.
50%. There were. I mean, it wasn't like a bigger thing. It was like 10 people. It was the so so the conference works like this. There are really local levels that are like around your school, like around your like neighborhood, basically, and then there's like
Yeah.
the city level, and then there's like the region level, and so at that level there were like 50% of the
Wow. That's
yeah
amazing. Yeah. It's
yeah
pretty cool.
yeah we've been working with my friend there on a project. We basically use a lot of convolutional neural networks uh, and design them in a way that that can potentially, and we really hope that we'll put in practice, help visually impaired people who can see to basically use the help of like convolutional neural nets and object detectors to and face recognition stuff that I'm getting into
Yeah, yeah.
to kind of leverage that and turn that into the audio format to
Uh,
help
that's really
help
cool.
see.
That was
Yeah.
with the bus numbers. Eh? I think I saw it on your Twitter feed. With the YOLO algorithm and the bus
Yeah.
numbers.
Yeah. That's what I'm basically doing here. I've trained you to detect bus doors, open and close bus numbers, then just how to run it, then I'm like now getting to face recognition, emotion detection,
Wow.
age recognition, and kind of exploring new ways of doing that. I've recently found out that I can get like much better accuracy. I've basically downloaded like 800 images from Google for women and for females and for males, and then instead of like using a neural network uh, to train like on like their face on just like the image of their faces, I use the embeddings. Do you know about the embeddings in like face
Yeah, yeah,
recognition? So
yeah.
like so extracted those embeddings from faces and then got two classes, male and female, as if I was like recognizing faces, like I
Yeah,
don't know,
yeah.
John, Ivan, Stig. So I
Yeah.
got like two classes, male, female, and by that approach, from like the images from Google, uh, the results were much better. They were about like 30 to 40% better than, maybe like 50%
Oh.
better than by just me pointing my webcam at Google and at myself, and than what I got with like the other neural nets. So, and I can of course get more data, and I'm kind of trying to build something reliable. There were a lot of fun stuff.
Yeah.
It was a lot of fun at the conference, but one of the problems was that neural network that was kind of responsible for detecting genders, it wasn't working properly, and that's kind of what got me here. So you can imagine, we launched the whole thing on the laptop. We get into the mode where it detects faces, and at a point, a camera at a girl, and it says like it's a and gets the emotion, like it's a neutral, it's like a calm, and it says like it's a boy, not a girl, and like the other way around. And that was embarrassing, but overall it worked.
So,
Yeah, yeah, and that was like that beautiful new word that I've learned from you. That is not word, but like the abbreviation, the proof of concept, the POC of ours.
POC, yeah.
POC, yeah. Gotta use them more often. Yeah. So basically, I handle the neural nets. My friend handles the sorting of the output, so that it can, so it doesn't just tell you, I don't know, like a potted plant here and like all the weird stuff, and it jumps to the importance. Like first kind of describes humans in the image, then cars and animals,
Right, yeah,
and also like sorts and outputs information for all the like different scenarios, and then handles the audio outputs that actually says that out loud. And right now we have it so that you can grab a laptop, put it in the backpack, get your phone connected to it via webcam, and plug a headphone from your phone in your ear, walk. Yeah, but
Nice. It's really cool. It's a cool
yeah, I mean,
engine.
there's a lot that can be improved, and we're working on it. But
Yeah,
yeah, the progress is encouraging. It's,
yeah.
it's,
I
it's
can
really well.
imagine. It's cool. That's
Yeah.
great.
But yeah, I was pissed off when it was like detecting boys versus girls and like the wrong way. Like, come on.
Yeah.
Uh,
Did
but
you fix it by now?
yeah, as I said, I got like better accuracies with using face recognition. So
Yeah.
I'll try to improve that even better by giving it more data. I've shown it the like I didn't show with kids, so I've shown like old people and then like adults and teenagers, but I didn't like specifically Google the kids pictures. So I guess it
Okay.
mistakes kids because the way kind of I guess that it works is once it kind of gets that embedded, it's got suddenly a lot more features to like look at, and maybe
Yeah.
when it's a female face, it kind of looks at. I mean, basically, a lot of faces of kids they kind of look like female faces because they're more similar to female faces than they're like to male faces.
Definitely, you don't have the
The
male
beard, the beard,
specific things. Yeah.
yeah, and also like boys are, when they grow up, they become more like masculine. So basically, I gotta show it
Yeah.
more of kids. It's kind of not
Yeah, it will
not
make
doing
a
that great.
difference if you add kids probably to your model.
Yeah, because like, yeah, but like, I think it's super cool because if we can get something that's computationally not that expensive and I mean, we're doing that for free and hopefully deploy that on a smartphone in the future. So, I mean, you can imagine if you, from not being able to see to being able to tell with a good confidence whether in front of you, like, a a man or a woman, or whether what's their emotion, whether like, they're smiling or they're upset, and
Yeah.
just being able to describe them. Like, for instance, you walk into the room, you don't know what that is. You see that there's a fridge and there's a stuff and there's food, and you can kind of guess that it's a kitchen. So yeah, I think that's
Yeah.
really there's a lot that can be done with it,
Definitely.
and
Yeah. Yeah, and it's a nice
working.
definitely very nice fit.
Yeah, and a good thing that like we're also learning along the way because basically all the things that you can use here you can use
Exactly.
to
Yeah.
make a robot or self-driving cars. So it's kind of also
Yeah.
building up the skills for the future. So
Yeah.
that's
Yeah.
so I'm really fun. So
Great.
yeah. I think we were talking about school, AI. at some point.
Yeah.
Yeah. And then went to the rabbit hole of saying what I was doing. But
Yeah,
yeah,
it was really cool. I'm impressed.
yeah, thanks. Maybe you have some recommendations on, maybe there's something that I should check out, some useful
Um,
application.
you were using the YOLO algorithm.
Yeah,
Did you look at other algorithms? I know there are some other interesting.
yeah. I'm thinking about it, but I haven't so far. But I'm really open to whatever works best. Do you
Yeah,
have like a
yeah. I'm not
recommendation?
sure, but sorry, sorry. Do you have a minute? My girlfriend, she was asking me
Yeah,
to.
of course. Yeah, of course. Wife approval is the most important thing.
Exactly. Yeah, I'm back. Um,
So I
so
just use
so
my magic pen to then cut that moment out.
yeah, yeah. No, we need to leave in a couple of minutes, so
Oh,
probably need
of
to
course.
close. But
Okay. Okay.
um,
Then we gotta wrap up. Yeah. Yeah.
sorry.
Okay.
Yeah,
Uh,
yeah.
so,
If it's possible. Yeah.
yeah, of course. So just if you have just a couple of minutes, you can finish by just tell your experience with uh just just what are you excited to work on now, and maybe yeah,
Yeah, what I really like
what are
now,
you trying to do?
I'm trying to get deeper into the math behind neural networks, and that's really it's really helpful to get a very good solid understanding of
Mhm.
what's going on, and try to yeah get a grasp of how you can make your algorithms better. So that's something I really like at the moment, and it takes a lot of time to go into deep, but I like it, and there again there are so many great resources available on the internet. There are all these great courses on Coursera and so on. So it's a great journey for me to
Yeah, and it's super exciting to see so many people just tuning in into the journey and attending the school with
yeah
150 people.
definitely
That's
definitely yeah
crazy. That's super cool.
yeah
Okay, so
definitely.
Stig, that was my pleasure, and I wanna virtually shake your hand.
Yeah, let's shake hands.
Let's shake it. Yep, yep, something like that.
Almost,
Okay,
yeah.
okay.
Okay.
Okay, I wish you luck with wherever you're gonna go. I hope that your traffic lights will behave somewhat like the smart IoT traffic
Yeah.
lights, and there won't be that many crazy traffic. I hope that wife approval doesn't limit you all too much, and one day we'll do something about it. Okay,
Great, great.
so thanks for listening. If you're listening, and yeah, yeah. Bye bye.
Bye, Ivan. See you.
Goodbye in your native language.
Tot ziens.
That's just, I heard that before with Carol. So not a surprise
I
for me.
guess so, yeah. Now you know what it means.
How do you say tatsi?
Tot ziens. Tot ziens.
Tatsis.
Yeah,
I
something,
like
yeah,
I
almost.
like that. Yeah, I'm gonna learn Dutch this way someday. So
Yeah,
yeah,
yeah.
okay. Thank you so much.
Yeah. Thank
Thank
you
you
as well.
so
See
much.
you, Ivan.
Enjoyed it. Gotta do that sometime again.